great to have you here at our last distinguished lecture of the year, last and undoubtedly best. So thanks for being here. Andy Jassy joined Amazon 20 years ago, I think, 1997, fresh from a Harvard MBA. Spent a few years doing things like leading Amazon's music sales. And then 15 years ago, sort of envisioned the idea of infrastructure as a service. So he and his team spent a couple of years creating AWS, which went live in 2006. And it's grown into a nice little business. I read on the weekend something like $3.5 billion in revenue during the most recent quarter, up 50% since a year before. So growing like gangbusters. Of course, lots of AWS users here. So I'm going to just sort of talk to Andy a bit, and then we'll have time for some of your questions later on. So let's go back 15 years to the origins of AWS. So you'd become Jeff's technical assistant, I think, or whatever it's called, and you had this idea for infrastructure as a service. So what were the key principles, and how did you sell it?
Well, first of all, thanks for having me, by the way. It's great to be with all of you today. There were a few things going on, I'll call it between the years 2000 and 2003, that made us think this could be a good idea. The first was we had this business at Amazon called Merchant.com, where we sold our e-commerce technology to third-party merchants. These are companies like Target and Marks and Spencer. And when we went to deliver that solution to those companies, it turned out to be way harder and way more time-consuming than any of us imagined. And that's because we had really kind of jumbled up a bunch of parts of our platform, growing as fast as we did the first 8 years. And to deliver these through APIs, which is the way that these companies wanted to consume them, it took a lot of decoupling and a lot of work that we just hadn't thought about before. So really, around the year 2000, we became a services company and really found religion about service-oriented architecture very quietly, just to deliver the solution we needed to for Merchant.com. And we also then decided that every single internal development team inside the company would be expected to have well-documented, hardened APIs so that the teams could consume each other's services without having to talk to each other. That was a big fundamental shift that happened around the year 2000, really with no fanfare. The second thing that was going on was around 2002 and 2003, we were adding a lot of engineers. And at the time, I was working, as you mentioned, as Jeff's technical assistant, or back then we called the job his shadow. And it was really like a chief of staff role. And teams were taking the same amount of time to get all the software projects done, even though we were adding lots of people, and everyone said when we add people, it'll go faster. And so I went and talked to a number of the product development folks, and they said, look, I know you guys think these initiatives should take 2 to 3 months end to end, but we're spending 2 to 3 months just on the storage solution, or just on the database piece, or just on the compute piece. And nothing we're building scales beyond our own projects. And all of our peers have the same problem. And they were super frustrated. They were as frustrated as we were that it was taking as long. And so that actually was a real surprise to us. I don't think we had thought about how hard the infrastructure piece was. And we realized there was a real thirst inside Amazon for reliable, scalable, cost-effective infrastructure services. And Amazon is a very deep technology company at its core. And we figured if we had this issue, it's probably likely others had the same issue. And so when we started thinking about the notion of building these infrastructure services, we really thought we just build them to allow our retail business to move faster. But we extended that idea over time because we thought others would probably face the same problem. And the third thing that happened around that time was that we were doing an exercise at Jeff's house during an offsite where we were kind of listing our core competencies. And we started off with we were good at providing a lot of selection, and we were good at fulfilling that selection. But as we spent more time on it, we realized, again, fairly obviously in retrospect, but we didn't really realize at the time, that we had become really good at running infrastructure services deep in the stack, compute and storage and database and messaging and content distribution. And we'd also become really good at running reliable, scalable, cost-effective data centers, which we had to because our retail business is such a low-margin business. And so we had been writing on this whiteboard. We had this consumer business. We had this seller business. And with this set of realizations about those competencies, we wrote down developers/companies. And we asked ourselves, if you believed that companies and developers would build applications from scratch from these infrastructure services, if the right selection of those existed, then you believe the operating system became the internet, which was a really different model than what's existed the last number of decades. And then we said, well, if there's going to be an internet operating system, what are the key components, which pieces have already been built, and which pieces, given what Amazon's good at, could we meaningfully contribute to? And when we looked at that in mid-2003, we realized that none of those key components of the Internet operating system had been built. And when we thought about what we were good at, and we've always been a technology company at our heart, we realized we could provide all of those key components of that Internet operating system. With that, we set about to build AWS and this broader mission, which was really to enable any developer or company to build their technology applications on our technology infrastructure platform. And I remember when we went away to kind of explore if there was a real business there, after we kind of came to that realization, I kind of left that job to go explore that. We came to believe there was a real business opportunity, and we came to a set of tenets that we thought really mattered in the business. And then we had to go ask for resource. And we don't do PowerPoint presentations at Amazon. We only do these 6-page narratives. And I remember with just this 6-page narrative, and we called it a vision doc, we asked for 57 people, which felt so ballsy at the time. Like, I was so nervous about, I wrote 30 drafts of this paper, and Jeff didn't blink. I think some of my peers thought it was interesting but weren't sure what to make of it, because we really were, everyone was focused on the retail business, but really Jeff and a guy named Rick Dalzell, who was the CIO at the time, they just didn't blink, and they didn't know no one thought it would be as big and as quickly as it has been. But I think we all believed it had the potential to be big if we could, move quickly and deliver something that developers wanted.
So you've partly answered this, but you kind of decided that scalable Unix cycles was the right thing to try to sell. And when Microsoft and Google moved into the cloud business, they chose to try and sell something else. And in some sense, these are great companies, right? But they doggedly stuck with trying to sell something that honestly people weren't ready to buy. So the way I think about it is you sort of moved up stack, added services as people were ready to buy them, and it's been a great business. But do you have any I think it's clear from what you just said why you started with scalable Unix cycles, and that's because that's what you were building on, and you figured other people would want to build on it.
Yeah.
Okay? Do you have any explanation for why these other folks insisted on selling something else?
I can only theorize. For us, it was really straightforward, and in fact, every business at Amazon has a set of tenets, and those tenets are really a set of guidelines that are supposed to help guide you when you have hard decisions to make. And when we wrote the tenets for AWS, we wrote it very much based on a combination of our history as well as our beliefs. And so some of the tenets there are that we're going to build low-level, highly flexible building blocks. We weren't going to make a lot of decisions for developers. We weren't going to be paternal and tell developers what they could or could not do. And that was based on our own experience of having made a lot of these decisions for developers inside of Amazon as we were building out our own architectures, and realized that there were so many other use cases that we didn't think about when we made those decisions that we really prohibited or slowed down our ability to pursue. So, what we pursued very much was born out of our own history and what worked and didn't work for us and what we wanted. I think that there's two categories of large technology companies who have pursued the same thing. I think, there's one category of large technology providers, like some of the ones you mentioned, who decided to build an abstraction much further up the stack. And, I think that I don't know exactly why they pursue that. I think some of it might have been just a feeling like the basic building blocks were too basic. That what people really wanted was something much more abstracted. And I think some of it may also have to do with, we were very focused in the early days on developers and on startups, and we still remain incredibly focused on them. But we had this perception that they would be the ones that would try the platform first. Their alternatives were much worse than enterprises. They tend to start and adopt any kind of new paradigm shift like this was. And that group of people is willing to dig into the details and stitch together the components, maybe in a way that enterprises weren't as likely to do. And so we started there, and then we figured that enterprises would choose to have a bunch of people who did some of that stitching, and then others who would want abstractions further up. And we'd build the abstractions later when we had some of that adoption. I think some of the other folks, either because their customer base and focus was more enterprise, And or maybe because they thought the building blocks were kind of too primitive and not interesting enough, started another spot. I think there's a second category of large technology companies that just took an ungodly long time to kind of get there. And I think for them, these are companies like Oracle and IBM and some of those folks. And I think for them, the model that we were pursuing in the cloud was so disruptive to their core businesses. I mean, the margin structure is radically different. The pricing structure is radically different. The delivery model is radically different. The way you take care of customers is radically different. So different that I think that you have that dilemma at a lot of large companies where do you really want to try and accelerate the cannibalization of an existing? Yeah, it is. Right? Yeah. And so I think that they fought as long and hard as they could. They poo-pooed it. And they said, first no one will use it, then maybe only startups will use it, and they won't use it for anything real. Then it was enterprises will never use it, then the enterprises will never use it for anything mission critical. And just, companies and developers voted with their workloads. And so now they're in the spot of trying to kind of spin something up, but it's 6-7 years late.
So did you envision the impact on tech startups in your original 6-pager? Okay, the notion that a startup doesn't have to invest in infrastructure has completely changed the cost model for tech startups, right? It's utterly revolutionary.
Yeah.
Sort of in some sense, VCs are in a completely different place than they used to be, and that's because of what you provide. Was that in the 6-pager?
It was actually. I mean, look, there are so many things in our business that have been surprises to us. Probably the biggest of which is it just took so long for the other large technology companies to offer something in this space. But I don't think in our wildest dreams we thought we would have a 6 to 7 year head start, especially because we're across the lake from another big company in that space, and we all know so many people at each other's companies. And so there have been so many surprises. But that, if you read the document, the mental model, the stated mental model, was that an individual in his or her dorm room or garage would have access to the same cost structure and scalability of infrastructure as the largest companies in the world. And give you an idea, back then we were talking about those largest companies being like PeopleSoft. And so that was really, we wanted to be part of enabling 1,000 flowers to bloom. And one of the real realizations we had inside the company as we were exploring the idea and putting together a plan was that we asked people inside Amazon how much of your time is spent on the differentiating part of your idea and how much is spent on the infrastructure. And we found that 70% of the time was spent on the infrastructure. And we're pretty good at as a technology company, I'd argue. And we could only imagine that number was going to be higher externally. And so we really aimed to flip that equation on its head. We wanted companies not to have to spend their scarce resource on the undifferentiated heavy lifting of infrastructure, and to be able to spend more of their time innovating for their customers and their business.
So have there been recent changes in your position relative to, for example, Microsoft? And Microsoft is a company that, for example, has a great story related to compliance and sort of security, things like that. Lots of big corporate customers, big corporations, sort of enterprises are now figuring out that they too should be on the cloud. One would imagine Microsoft has a relationship advantage with some of those companies that you have to respond to in some way.
Well, if you look at the market segments that AWS is addressing, it's infrastructure, software, hardware, data center services, and then we're building software further up the stack. That's trillions of dollars globally. There's not going to be one successful player. I don't think there's going to be 30, because I think scale really matters here, both with regard to cost structure as well as the breadth of services. But there are going to be multiple successful players, and who those are, I think, is still to be written. But I would expect that several of the older guard players will have businesses here, as they have large installed enterprise customer bases and a large sales force and things of that sort. I think there's a lot of work those companies have to do to have the type of functionality that you find in AWS today. I mean, we have a lot more functionality by a large amount than whether it's Microsoft or really any other provider. And most of the big companies, enterprises included, and for reference, we also have a much larger set of security capabilities and compliance capabilities than you'll find anywhere else. And what's happening is most enterprises are making decisions around how many companies do I want to use in the cloud? Do I want to move to the cloud? How do I want to do it? How many companies am I going to use? And most are predominantly deciding they're going to use a single provider. Many will have a second provider they use for a relatively small percentage of their workloads so that they know they can move should they decide they want to move. But the benefits of being with a single provider around not having to standardize on the lowest common denominator, not having to have your development teams have to be expert on multiple platforms, and then leveraging your buying power across one provider instead of splitting it across 2 or 3 are just too great when you actually get into the practicality of it to split it across a few. So most are predominantly picking an infrastructure provider. And a lot of what matters to them at the end of the day is the breadth of capability that's there, because it not only allows them to build any new application or idea they have, but most of them are looking to migrate their existing applications over the next few years, and having the right tool for the right job allows you to be much more cost effective and agile, which is what a lot of them are trying to do.
Presumably the switching costs go up as they go up stack, right? If you bare Unix cycles, the switching costs are pretty low. Are people nervous about this?
I think
customers?
that customers will always be nervous about lock-in. And I think that the experience they've had, particularly with a company like Oracle, where it's a really hard thing to get out of, and they're so hostile to their customers that I think that it's a concern for every enterprise. And almost always when I talk to enterprises about lock-in, that's the example they cite, and they worry that they are going to use a platform and suddenly you're going to start raising prices, even though we've lowered our prices on 59 different occasions with no competitive pressure to do so in the last 8 years. So they're going to always be sensitive about that, and they should be thoughtful about it. But the reality is it's so much easier to move from the infrastructure cloud computing platforms than it is from something like Oracle, that the APIs look pretty similar. All the migration services we build allow people to move to us or away from us and back on-prem if that's what they want to do. And so, and the business model is different, where we're not signing these 5 to 10 year unlimited licensing agreements, and then finding ways to audit people and keep them in the loop. I mean, they can leave whenever they want, and we know we have to earn the business every hour, every day, every week of the year.
I'm laughing because I asked a set of people to suggest questions, and Bill Howe over in the information school said I should ask you, why do you say those mean things about a nice guy like Larry Ellison? But I'm not asking that question.
It's not personal. I mean, people ask all the time. A lot of the frames of reference for enterprise and how they think about new emerging mediums like this is just what they've been using for the past 30 years. The reason that AWS was one of the reasons we were as successful as we were, as quickly as we were, is that people really disliked their infrastructure and software solutions over the last few decades. People really wanted to change.
Let's talk about your infrastructure for a minute. We were talking about James Hamilton before, and at reInvent, he gave this incredible talk about the amount of custom hardware you're doing. And I think that's an area where, we read about Microsoft's FPGAs at the top of racks, and we've known about, Google's custom servers for a long time. I'm not sure it had registered on me before James's talk, the amount of customization you do. So talk a little bit about, this is custom firmware and power switching gear and routers with custom chipsets and things like that. It was quite amazing.
Just in general, I would say that Amazon tends to be a little bit more quiet and close to the vest about those things than some of the other technology companies. So I think use it in part to recruit. And, I think it's a perfectly rational approach that some of our competitors take. It hasn't been ours. But you can imagine with the scale we're at. I mean, just to give you an idea of scale, every single day we're adding enough new servers to have managed all of Amazon when we were about a $7 billion business globally. So that's every single day we're adding that number of new servers to have handled a $7 billion global business. So when you're at that type of scale with millions of customers using your platform, you start to emerge from buying racks off the shelf to doing contract manufacturing, to designing your own servers, to designing your own networking gear, to designing your own firmware, to sourcing all of the components that go into this gear yourself. It makes sense both from a cost perspective as well as a visibility perspective. Just in the networking space, which has been relatively, one of the last parts of the stack to commoditize, we just found it was challenging to really have the visibility into operational events if we didn't have more control over the software. There would be something that would go wrong. We would know it went wrong. We'd ask about it. We'd have to wait for somebody to respond. Sometimes they responded quickly. Sometimes they didn't respond quickly. In the meantime, our customers want an answer right away. And so some of these, there's for sure cost. There's optimization around performance. And then it's also just the ability to have visibility into how you operate at the type of scale we are. So there's a huge amount of IPs, in our data centers and, in addition to the services as well.
How about retrofitting old data centers? You're building new ones like crazy.
Yeah.
How long does one last?
Well, we've moved out of several of them, but we have gotten a fair bit of utility from data centers that we might not have guessed we would have had as functional as long as they are. So, we always assume 10 to 15 years is about the useful life we'll get. So many of our data centers, the vast majority of our data centers are, within that 10 to 15 year time frame. But
what's the lifetime of a rack of servers?
It's again, it varies by server and but we're changing pretty quickly. I mean, as soon as the new processors are coming out, and we have a deep relationship with the Intels of the world, we are always incredibly quick to be using those. And then we kind of look at what customers say with regard to, do they want to use, you'd be surprised, we have in EC2, which is our compute service, we have instance families, and our M family is kind of our general purpose family. And we're kind of at this point on the M4 generation, but you'd be surprised how many of our customers don't want to move from the M1s, even though they're a fraction of the capability of the M4s. I think if something's working well for customers, a lot of times they're loath to spend time trying to change it. And so, in general, though,
so are they in fact still running on M1 processors?
We have many who are. I mean, it's the minority. Over time, what happens is people want to use the new capabilities.
You were giving them M1 class of service out of M4 class of
No,
processors.
we still. I mean, again, each year the amount of servers that we've had for several years decreases, just because customers, understandably, don't want to run on something less capable, and also the density of these racks is so different that from a productivity standpoint, you kind of want to be using the denser racks. And so, both because customers want it and the way we price, it tends to be every few years that customers are using the new generations. But we still do have, because we have millions of active customers, we still have a small number who are using those instance families from several years ago.
Can you talk about the power efficiency of a data center now versus 5 years ago or something like that?
Yeah, it's pretty radically different. Again, just a lot of innovation, around the way that we do our power manufacturing and engineering, and what we've built, the way we work with switchboards, the way we work with UPSs, the way we do cooling. I mean, all of that. There's quite a bit of IP and quite a bit of invention in there. And the thing that we're also spending a fair bit of time on right now is how to use as much renewable energy as we possibly can, and without trying to build our own grid, which we don't think is probably a cost-effective activity. We are, as has been publicized, we're funding a lot of power projects at this point, so we're making a lot of progress there as well.
So here's a really naive question. I have no idea how much of Amazon's retail business either runs on the same AWS I run on, or runs on the same architecture, even if it's a separate data center or a separate rack or something.
Yeah, no, the vast majority is running on top of the same AWS that you run on top of. And we have each year goals around whatever is remaining about trying to move those, and some of those are the gnarliest things to move. And we in the early days of Amazon, Jeff and the team bought a lot of Oracle, and so we have systematically been trying to lose the last bits of that. That said, it's we're going to always have a mix. We started at a certain point, and this is true of all enterprises. You start at a certain point, people get used to running those applications there. They have competing goals. They have to decide how much of their time they're going to spend on kind of reworking the existing applications versus building new ones. So, really for us, at this point, the biggest applications that haven't moved are the ones that have, they have the most amount of legacy, the most amount of dependencies. They're ones that were built a long time ago where you have to be careful because not all the people who built them are still there and you don't know what you may break. These are things like financial services systems, some of the, I'll call it some of the older HR systems. Those are really kind of the last to move, and we're working on getting the last of those done in the next 18 months.
So I wish I could find this because it's pre-web, but I remember that an ad in like Datamation in the middle 90s, and Jeff Bezos was in an ad for DEC Alpha servers, or maybe they were HP Alpha servers. The idea of Amazon running on a symmetric multiprocessor, and that being, the company, is just mind-boggling. You think about what a joke that is as a way to run a web service these days. You've been through so many generations of architecture.
Yeah, it's, we've been through so many kind of big shifts. We went from these, very expensive servers and boxes, and we used all the big ones, Sun, and over time we first we really transitioned from really Windows to Linux, and that was a huge initiative that took a lot of time and a lot of effort across the company. They all had these kind of very elaborate code names that make you shudder if you've been at Amazon for a long period of time. And and then we went to commodity boxes and machines, which was also a big shift for us and a really important one. And I think the most important shift, though, that we really went through was the one I referenced earlier, which is really what people now call microservices, but at the time we just thought of it as building with these hardened APIs that were well documented in this service-oriented architecture fashion. And that, that totally changed how we thought about technology, building software, the speed with which we should move. We used to have this process inside the company called MPI. I'm not even sure I know what it stands for. I think it was New Product Introduction, but no one ever called it anything other than MPI. And basically, if you had an initiative in the company where you wanted to, where you had a project that touched more than 2 internal development teams, you would have to go to these every 6-month NPI cabals, and you'd present your idea. It was this big table, and then when you were done, people would hold up a card that said how many people weeks from their area. And so it was really depressing. If you had a good idea that everybody liked, and you got done, going around the room, and it was something like, 4 people years to get it done, we would have 20 good ideas and choose 3. And we would never know which 3 to choose. And it was often the ones where the more aggressive people with the higher NPVs were the ones that carried the day. And we just hated that. And so for us, the service-oriented architecture was as much about killing the NPI process as anything else, where we could go pursue those 20 ideas and the teams could do it without having to talk to one another. And I think one of the least well understood stories the last 5 years, because people have gotten interested in AWS, is how fast our consumer business has moved, building on these same AWS building blocks. And it's just because we think of it in a much different service-oriented architecture way.
So let's talk about security hardware features. I assume you're doing a bunch of this with your own architectures, but now we see, Intel's SGX and things like that. Where do you think we're going in terms of sort of security features?
I think we're, there's so much security built into these cloud computing platforms today. For us, it's our number one priority. It's not even close relative to anything else. And we have a very large and very capable security team who's built a whole bunch of not just security capabilities, but compliance capabilities for customers, and then also external security services. We had so many of our customers who were using us and asking us to do things like pen testing and vulnerability testing and all kinds of network testing, and they asked, would you just expose those as external services? So we have a lot going there, but we have a separate group of people who do nothing but look at the new technologies. And some of the technologies you're referencing, I would say, are still pretty early and aren't necessarily yet ready for the server space, but they'll be there. And a lot of times we get asked from VCs, what are some of the great places for us to be encouraged to invest in as it relates to the cloud? There is, if you believe like we do that very few companies will have their own data centers 10 years from now, that means all that computing is moving to the cloud. And if you believe that, there is a very healthy appetite in companies to have all kinds of security protections everywhere. I mean, even look at something like what's happening at the edge, today. I mean, I think in the future, I think most companies' on-premise footprint is not going to be servers. I think it's going to be these IoT edge devices that are proliferating in offices and factories and oil fields and agricultural fields and planes and cars. I mean, just everywhere. And if you think about the security associated with them, it's totally different. I mean, look at the big DDoS that happened to Dyn at the end of last year that was launched on one of those IoT devices. Yep. And so the security challenges and the identity challenges and the communication challenges there, it's just greenfield. And so I think there's a lot of innovation and development ahead of us there, and we're excited about it. We'll do some of it, and we'll also partner with other companies.
So let's talk for a minute about universities in the cloud.
Okay.
I've been associated for nearly 10 years now with the Data Science Initiative here, and part of this is just trying to get people off local servers and onto the cloud, and it's a bit of a struggle, and sometimes it's these funny diseconomies at universities, right? We don't pay for our power, we don't pay for our cooling, we don't do backups, stuff like, these have real costs. But, I keep trying to ask people, what is it that that Netflix doesn't, that causes them to put their business on AWS. Can you tell some stories about major research projects at universities here or elsewhere that have been really successful in AWS?
Well, I'll give you some examples. I mean, we have virtually every large university is doing something significant on top of us, and Berkeley has been for a really long time, and Harvard and MIT and all the it's a very large number. Notre Dame is effectively going all in on top of AWS. Georgetown. I mean, there are a bunch of universities that are basically just saying we're done with the model we've been using. But I think that I really liked the story of what Novartis did. Novartis is a large multinational pharmaceutical company that has a big research arm, and they wanted to basically do virtual screening on 10 million compounds against a common cancer target. And in the research group, it required about, it was about 50,000 cores. It was about 39 years of computational chemistry that would have taken them many months and would have cost, the estimate was it would have cost about $40 million. They did that same computation in 9 hours on AWS for $4,200. It's just it's just a very different type of model. Or you can look at, we work closely with NASA. NASA's been able to do in just a few days. They basically were able to assess the number of trees in sub-Saharan Africa, and they, it was a large amount of data that they basically, moved, stored, processed, and the whole initiative took them 3 days and $2,000. And so, there's just a lot of those types of examples. And the reality is, the same rationale that you're talking about for researchers, we have seen over and over again in the enterprise as well as the government and the public sector, which is if somebody doesn't do the right apples-to-apples cost comparison, you say, oh, we've already paid for the data center, we've already paid for the networking gear, we've already paid for the servers, and and then they often don't count the people who have to do all that work, and you end up thinking it's effectively free. And the reality is that's not how the costs actually lay out. And and we were talking about earlier, the average customer for us is kind of moving every 2 to 3 years to a new instance family and the newest technology. Well, those are tech refreshes, and those tech refreshes cost money, and the data centers, as they come up for renewal or refreshes, that costs money, and the number of people to operate them, and then of course the services at your disposal. The main reason that enterprises and governments are moving so fast to the cloud, cost is an important conversation starter, but it's not the main reason. The main reason is agility and speed. And some of that is being able to provision thousands of servers in minutes. But a much bigger part of it is because we have 90 plus services at your disposal, you don't have to figure out the compute or the storage or the database or the messaging or the analytics or the machine learning or the content distribution, and the list goes on and on. You get to use those services that we've built, that we make available by the drink. And so it means that you can get from an idea or a thesis to actually experimenting and trying that idea and learning in orders of magnitude faster, because you don't have to build all those things around it. And the same is true here, obviously, with
universities. For us, collaboration and sharing is a big plus, too. It's the fact you can work with somebody somewhere else with no hassle at all, as opposed to getting credentials.
We have, just for perspective, we probably have about 25 people at the company in AWS who do nothing but these apples-to-apples TCO analyses, because there are a lot of times where teams inside enterprises or universities, for lots of different reasons.
They get a paycheck based on convincing me that my stuff could never run on the cloud.
Yeah,
right?
and if you don't force yourself to do the right apples-to-apples comparison, you'll be fooled.
Let me ask one more question. Talk about a few of the services you've launched recently. So, for example, the data pipeline, it's not really recent, but it's become pretty large. What are the sort of big services in the past year?
Gosh, there are a lot of them. I'll kind of bucket them in categories. On the analytics, we have really the broadest analytics offering by a large amount out there, and we have managed Hadoop, managed Presto, managed Pig and Hive and Spark, and literally, we've got about 10 of these Hadoop variants that are managed, and we manage Elasticsearch and a data warehouse and a business intelligence service. So we have a very large analytics offering, and yet we keep finding that customers have new ideas that they ask us to build that would make it useful for them, more useful and easier for them to get done what they want to do. And so, at our conference, which is called reInvent, at the end of the year, we launched something called Athena, which really allows people to do querying directly on S3, which is our storage service, and that they don't have to worry about moving the data. The vast majority of companies using the cloud today have the data stored in S3, so to be able to query directly on it and pay by the query is very attractive to people. So the people have been very excited about that, and it's off to a really great start. We announced at the same conference something called Glue, which is related to the data pipeline we're talking about, which really is, when you talk to a lot of big companies, really one of their biggest challenges is ETL. How do you actually get the data in? How do you normalize it? And how do you make it easy to kind of get from place to place? And today they kind of have to do it service by service in the cloud. And so we launched an ETL service called Glue that people are really excited about. In the machine learning space and the AI space, we've been doing that for a very long time with the company. That's another example of something like we were talking about, the infrastructure pieces, where we haven't talked that much about it historically, but we have many thousands of people in the company who just do AI. And if you think about the very earliest recommendations for Amazon, were informed by machine learning algorithms. The pick paths for the people in our fulfillment centers is really driven by deep learning algorithms. Alexa, which a lot of people know as part of our Echo type devices, really sophisticated NLU and ASR. And so a lot of our customers wanted us to expose a bunch of those pieces for them. And so we exposed the image recognition service, a text-to-speech service, and then the technology that's in Alexa, which we call, we released a service called Lex, is now available for people to build conversational apps. And so we have, we think about machine learning really almost like 3 levels of stack. There's the highest level, which are some of those services I just mentioned that are really come almost packaged. You pass us an image, and we'll tell you what's in the image. The lowest level tend to be really the expert practitioners that want to build on those deep learning engines. We have and will continue to make all of those deep learning engines work really well on top of AWS. And we've built a bunch of AMIs, packaged AMIs for all those deep learning engines, and we have a huge amount of machine learning being done. We're tending to invest more of our energy in MXNet just because it scales the best. And the type of problems a lot of our customers are trying to solve are really broad and high scale, but we'll make them all work well on top of the platform. That said, there's still a relatively small number of expert practitioners that can really do the work required at that lowest level. You guys are helping us find more and more of those people. Thank you, by the way. But if you look at everything that we've done in AWS, we have really tried to democratize the technology for everyday developers to be able to build whatever they could imagine. And that ranges from startups to developers of large companies or governments. And so we're also very focused on trying to make that, what we'll call that middle layer of the stack, much more accessible to developers. Still most aren't comfortable kind of building the models, refining the models, doing inference, figuring out how to get that data into production apps and things of that sort. It's still way too hard in our opinion, and we're working hard on that as well. So I'd say that area is another area, the machine learning space. The last one I'd probably point out is just the edge. I think that we have this perspective, which we've been sharing for a bit now, that most enterprises on-premise infrastructure is going to ultimately be at the edge. And these edge devices have relatively little CPU and relatively little disk. So the cloud becomes disproportionately important as a supplement. And it's why you see most of the big IoT implementations are leveraging AWS. Illumina has their genome sequencing machines, integrated with AWS to do the massive large-scale analytics, or StatCast. If you ever watch Major League Baseball and you see the StatCast feature, that's all their ballparks have these tiny data centers that are then streaming that data through Kinesis to AWS and doing analytics, and then providing the data on the other side of those features. Or John Deere has 200,000 telematically enabled tractors that are capturing planting conditions data and then doing analytics and telling the farmers the optimal conditions to which to plant. All that's using AWS. But what you also find is that the people that have these devices at the edge, they have certain functions that they don't want to make the round-trip visit to the cloud. They don't want to take that latency. Or sometimes they're in conditions where they just don't have the connectivity to do it. And so what they really want is they want to do programming on the device or the assets themselves, so that they're using effectively the same functions, event-driven functions they use in AWS to do the same things on the device. And so it's why we released something called Greengrass, which is really like a software module that you can have on a device that give people effectively Lambda, which is an event-driven computing model, inside of it, so that developers can write the functions they want once and deploy it to both the cloud and the device. And that is so much easier. I mean, if you try to program on these devices, you have to be really a deep embedded device developer to have any luck, and then you have to hope that you don't bring the whole thing down when you do it. And so trying to make the programming model consistent across both the devices as well as what they're going to want to do with the large-scale analytics in the cloud is something that's a focus as well.
A couple questions from you folks.
So between the vision of AWS and having it working, what was the hardest part? Because actually, people have had visions like this for a long time. The problem is that they fail.
Yeah.
So what?
Yeah, we are definitely not.
Repeat the question.
The question was, I think, between having the vision for AWS and making it work, what's been the hardest parts? Because a lot of people have had visions that just haven't worked, and we definitely are. There's always a fair amount of that's luck. I mean, I think anybody that's done anything new that's worked well that acts like none of it was luck is really full of it. So you have to have the right timing, and some things have to break your way. But I think there were a lot of things that happened. I mean, I think the fact that people were broadly virtualized before we started working on this helped in all kinds of ways. I think the cost, the continued decreases in Moore's law helped. But I think a lot of it, I think that...
Was there some technical thing you really beat your head against?
Yeah, I mean, there were a lot of them. I think the decision to build in these primitive building blocks turned out to be a good decision for us. I think that when you're moving to something really new like the cloud is, the more it can kind of look like things people have used in the past, but with an advantage model or set of performance or cost characteristics helps with the adoption. And so the fact that an instance kind of looked like something they'd interacted with before, except it just wasn't in their data center and they can kind of have more elasticity and they can move more quickly. I think having those primitive building blocks was very helpful. I think giving people the freedom to make the decisions on what to stitch together was very helpful. I think the pricing model was very impactful early on. You know, we did a lot of, people gave us a lot of credit early on for the pricing model, and I always thought that was overblown because all we really did was try to deliver what we heard customers tell us mattered to them. We talked to a lot of customers internally and externally, and they just hated the model that existed before, where there was all this, you know, basically all this slippage, you know, having to sign up to these very large long-term deals and before they knew whether they needed it or not. And you always provision for the peak, so there's a reason they call it the peak, so you're sitting on all this wasted money. And I think the pay-by-the-drink pricing model turned out to be very influential. I think, honestly, that we very consciously targeted developers and startups early on, even though we thought that enterprises and governments would probably be the largest absolute users just because they have the most amount of absolute infrastructure. But that turned out to be an extremely underserved segment at the time. I think most of the large technology companies, for whatever reason, just weren't that interested in what developers wanted. I think maybe because, you know, so many of them were going to spend $10 a month. You know, we didn't mind that, you know, because we also knew that when you allow people to spend $10 a month, some of those are going to be the next big enterprises in the next 5 to 10 years. You can't cherry pick which ones. So we were always focused on trying to allow developers to invent the next big invention, which I think was useful as well. And I think the last thing I would say is that it's really hard to pick where to draw the line on V1. And, you know, sometimes you can get it, you know, sometimes 80% of the necessary functionality allows you to get 0% of the business. And we had these massive, when we were launching EC2, we had these massive internal fights and debates about, can we launch it with just Linux and no Windows? Can we launch it without persistent storage, which is now EBS? Can we launch it with no monitoring, with no load balancing? You know, with all these things. And I think that we had this thesis that in big new shifts in the cloud, we thought had the chance to be one of the big shifts of our lifetime. You're much better served in being first to market, as long as you have ways to capture the feedback from customers on what really matters, and then you can organize yourselves to iterate quickly. So being, you know, quick, you know, moving fast, and being feature poor to start with only works if you can actually deliver on iterating quickly. And, you know, I think the decision to do that, to get a lot of that thought leadership and a lot of that early customer feedback, which really drove what we were going to do, which was different from what we would have guessed right off the bat, and then being able to deliver as fast as the team has delivered, have all been reasons that it's been, you know, come to pass. Yeah.
First of all, thank you for coming. I'm an MBA student. I'm particularly interested in the artificial intelligence area. So I have learned that AWS is providing its customers with some SaaS services based on artificial intelligence algorithm, but more on the general purpose side. Because after all, there you have the mass market, right? But what's your strategy on the groundbreaking artificial intelligence technology? And what kind of business value are you envisioning that you can provide to your customers based on those incoming cutting-edge technologies?
Well, it's, as I was mentioning earlier, artificial intelligence is a huge area of investment and focus for, you know, both for AWS as well as Amazon as a whole. And we have a large number of people who are working on next generations of all kinds of areas in artificial intelligence that we think are important to figure out how we can leverage. But very often, you know, one of the things that's interesting about Amazon, and I'm not saying it's right or wrong, just again happens to be the way we do things, is we don't have a big R&D group as some other companies do. And that's very cultural for us, which is, I think if you look at the history of those, there's been so much waste, you know, and we tend to try to figure out what are the customer experiences and businesses that we want to enable. And there is no shortage of very big thinking at the company about what we're trying to enable. And I think you see every year all of the new experiences and businesses that we're pursuing. And what turns out to be the case is a lot of the things that we're envisioning require the use of AI and robotics and all kinds of areas. And so we find that hiring people and then focusing them on solving these problems, they're going to lead to potential businesses that we want to pursue, has been a much more practical and productive way to employ those resources and to learn about them. The other thing is that if you have just if you're interested in the technology just for the technology, there's innumerable paths you can go down, and it doesn't always lead to something that actually ends up being worth anything. And so I think that it's really, you're going to have to learn about the technologies any which way you cut it, but having some ideas, some practical ideas about how you might use it, I think has been part of why I think we've been very effective with the large amount of resources we've applied there. So we have a big investment there. I would say that our capabilities are probably ahead of the curve of what most large companies are ready to use yet, but we passionately believe they will over time, and we'll expose virtually all of those through services.
One more. You pick.
I'll pick someone up top. If someone up top is one, otherwise go ahead.
So this follows up maybe a little on Ed's question about hardware. We are supposedly coming to the end of Moore's Law. I guess maybe it's a two-part question. Do you see that impacting the way we do any of this? And are you investigating, like the people across the lake, different technologies to maybe do something different?
Yeah, it's a good question, and the answer is yes to all those things. I mean, I think Moore's Law is not necessarily going to end soon, but it certainly seems, the signals from for some of the providers are really, the primary provider in that space is that it's slowing down. And I think there's a lot of, there's quite a bit of ideas, I think, in the industry on how to try and, diminish how quickly it slows down, but we'll have to see. And as such, for us, hardware is a really important part of our cost structure, but it is just a fraction of the cost structure. If you think about what we do with data centers, you think what we do with the networking side, and you think about, we have a whole bunch of costs. So we also, we bought a chip company in Israel called Annapurna a couple of years ago, and that has been very helpful for us with regard to understanding the space even better. And I think, honestly, even though we use it for acceleration and some of the networking pieces we get, we also I think we're a better partner to some of our hardware and chip providers, because I think we're just better informed about some of the possibilities. But there's no question that that's something that I think everybody in the industry is thinking about and everybody's planning around. And it makes you have to think really hard about how to be efficient, not just with the hardware component, but with all the other components of your infrastructure, including utilization, which is a big driver, and how profitable you're going to be in an infrastructure platform like ours. So there's a lot of focus on it. There's a lot of discussion about it. I think there are a lot of people trying to figure out how to continue to take costs down.
So it's time that we break. Before we thank Andy, let me mention there's a reception in the Allen Center atrium. I hope you'll join us. Andy will be there for at least a bit. I also want to mention, you've noticed the big hole across the street where our new building is going to go. As many of you know, there will be an Amazon auditorium in that building. So Amazon, Microsoft, Zillow, and Google have all just been extraordinary in making it possible for us to create the space double enrollment. So Andy, thank you for that, and thank you for being here today.
It's our pleasure. Thank you. I'm happy to be here.